Patch complete. Now so why sulfuric acid is called as oil of vitriol? Why sulfuric acid? Why concentrated sulfuric acid is called as oil of vitriol? Answer is concentrated sulfuric acid is oil of because of its oily appearance. Sulfuric acid is actually oily, and the fact that it is present in vitreous or glassy substance like ferrous sulfate, alum, etc. This is the answer. Or you can write the reaction. Previously we have mentioned the reaction that is prepared from ferrous sulfate or even from alum, etc. It can be prepared different sulfate salts. Now we want to discuss its occurrence. Occurrence, where from you get the sulfuric acid.
So can you show the previous slide?
Okay.
Yes. Thanks. Thanks.
Now we want to discuss the occurrence of sulfuric acid. Now, occurrence means in which form sulfuric acid present in the nature. That is two different forms. That is just like other cases also. One is free state and another one is the combined state. Free state, that means it present as sulfuric acid in hot springs or near the sulfide beds by the hydrolysis of FeS2. FeS2, that is the iron pyrides. FeS2 iron pyrides. It is produced by the hydrolysis of iron pyrides. That is actually a natural process. In the nature, we get the one of the important ore of iron, that is the iron pyrides, and iron pyrides, when hydrolyzed, they produce some amount of sulfuric acid, not a large amount but some amount, and traces of concentrated sulfuric acid, you should say, traces of sulfuric acid that is present in hot springs also. In combined state, that means it is not present as sulfuric acid but in a combined form, like when you say like sodium sulfate, it is actually combined state of sulfuric acid, because here sulfuric acid is not present as it is, but it is present in uh, in it present as a sulfate salt. So sulfate salts are also considered to be the presence of sulfuric acid in the combined form. Like when you consider that sodium hydroxide, it reacts with sulfuric acid, then it produces sodium sulfate. So sodium sulfate is the combined form of sulfuric acid. In different types of minerals, sodium sulfate, calcium sulfate, aluminium sulfate, these are the important minerals in which sulfuric acid is present, but not as sulfuric acid. They present in the combined form of the other metals, combined with the other metals like sodium or potassium or the ammonium, etc. So sulfuric acid is present in different states, free state or combined state, and the free states are two different types and the combined state So many types, but the type actually we mention only one type, that is the metallic sulfate. That is the metallic sulfate of different metals like sodium, potassium, calcium, aluminium, ammonium, etc. So this is the occurrence of sulfuric acid. Now, initially, there are different methods for the preparation of sulfuric acid um, in the laboratory or even in the industry. Here we discuss some of the general methods of preparation of sulfuric acid. First, here you see that we can convert nitric acid into sulfuric acid. Nitric acid into sulfuric acid by the reaction between sulfur, elemental sulfur, and the concentrated nitric acid. Here you see that by the action of heat on nitric acid and sulfur when reacts with concentrated nitric acid. Now, nitric acid is a good oxidizing agent. Okay? Oxidizing agent. So it can oxidize. Nitric acid oxidizes sulfur into sulfuric acid. So sulfur is converted into sulfuric acid by the oxidizing power of nitric acid. Now, one important point is that nitric acid is a good oxidizing agent. So when nitric acid oxidizes other, itself get reduced to nitrogen dioxide. This is the important aspect of this reaction. Now, when you read any reaction, then in those cases, as we all know that around 95 to 96% reactions are redox reactions. So if you read any type of reaction, not only the redox reaction, but also in case of other reactions also, but most of the cases you should face the redox reactions. Now, in redox reaction, you have to know which one is the oxidizing agent, which one is the reducing agent, and the oxidizing agent or reducing agent, how itself get reduced or itself get oxidized into other forms which are formed as the product. So reactions, do not read reaction just like memorization. Read reactions on the basis of the fact that which one is oxidizing agent, which one is reducing agent, and how they convert themselves into the different products. That is most important part. Here you see that nitric acid, whenever you can be asked in this way that can you convert nitric acid into sulfuric acid? Can you convert nitric acid into sulfuric acid? How will you convert nitric acid into sulfuric acid? Now, what important property of nitric acid is used in this reaction? That all the questions should be answered on the basis of the fact that nitric acid is a good oxidizing agent, and it oxidizes sulfur into sulfuric acid and itself get reduced into nitrogen dioxide. So these are the important facts that you have to know from this particular reaction. So this is a very good method for the preparation of sulfuric acid, but this method is not an industrial method or the large scale method, only because of the fact that the conversion of sulfur into sulfuric acid, there's a very less amount of yield, or the rate of conversion or the reaction rate is very slow. That's why this reaction cannot be used in industrially for the preparation, large scale preparation of the sulfuric acid. Now we move on to next method, where you see that the important in the sense that here we get a reaction. We see a reaction where both the acid, sulfuric acid and the hydrochloric acid, both produced in the same reaction. Here you see that chlorine gas is passed through aqueous solution of sulfur dioxide. Here you see that both the acids, hydrochloric acid and the sulfuric acid, both acids are formed in the same reaction. So it is a very important reaction where both the acid, very much important acid in the laboratory. When you see what are the important acids present in the laboratory, that is three important acid, that is the hydrochloric acid, sulfuric acid and nitric acid. But here you see that two acids produced in the same reaction, that is the hydrochloric acid and the sulfuric acid produced in the same reaction. So you can be asked in this way that give an example of a reaction where the two important laboratory acids produced in the same reaction. So here you see that chlorine is passed through an aqueous solution of sulfur dioxide, convert themselves into hydrochloric acid and sulfuric acid. Here you see that chlorine acts as oxidizing agent because chlorine itself reduced with the formation of HCl. So in this reaction, chlorine acts as oxidizing agent and sulfuric acid acts as reducing agent. Here chlorine acts as oxidizing agent and sulfur dioxide acts as reducing agent. So this is another method for the preparation of sulfuric acid. Not only sulfuric acid, or you can use this reaction as the preparation of hydrochloric acid also. Now move on to the next one. That is the most common method, that when the oxides of non-metal dissolve into water, they produces acid. Now here you see that sulfur is a non-metal and its oxide is sulfur trioxide, or even you can say that sulfur dioxide. But if you take the sulfur trioxide and that is dissolved into water, you get the sulfuric acid. Now this is most common method, for the preparation of sulfuric acid. Now, because of the fact that the principle is when a non-metallic oxides are considered to be acidic or basic. Non-metallic oxide are basic oxide, not basic oxide. Actually, non-metallic oxides are acidic oxide. Like if you consider sodium oxide, it is metallic oxide, this is basic. Potassium oxide, calcium oxide, all those oxides are basic in nature. Carbon dioxide, sulfur trioxide, P2O5, all those oxides are acidic oxide. Can you give any example where the metallic oxide is acidic? Do you know? Any one of you? Acidic oxide but metallic. Acidic oxide which is metallic. হ্যাঁ বল। হ্যাঁ দেখে মোটামুটি দেখেছি আর কি। হ্যাঁ, এবার অঙ্ক ছাড়া যে তুই অন্য সাবজেক্ট দিবি সেগুলো তো মানে কম 35% মার্কস তো দরকার। হুম হুম না, অত ডিটেল আমি দেখিনি, বল। ম্যাথস ছাড়া দিতে গেলে কম্পিউটার সায়েন্স দেওয়া যাবে না, ম্যাথস হলে বায়োলজি আর বায়োলজি দিয়ে দিতে হবে। হ্যাঁ, ফিজিক্স কেমিস্ট্রি কম্পিউটার অ্যাপ্লিকেশন। ফিজিক্স কেমিস্ট্রিতেও তো অনেক কম নাম্বার, অ্যাভারেজে 35% হয়ে যাচ্ছে, তাই তো। না, হবে না। ওটা হয়তো হতে পারে। হুম। ও, বুঝতে পেরেছি, কিন্তু দিয়ে কোনো লাভ নেই। যে মানে এই বোর্ডেতে অঙ্কেতে এই নাম্বার পাচ্ছে, মানে ও কিছুই জানে না আর কি। হ্যাঁ, মানে ও কমার্সেই পারবে না, মানে এরকম ধরনের স্টুডেন্ট। মানে কোনোটাতেই নাম্বার নেই, আমি দেখেছি কোনো কিছুতেই নাম্বার নেই। হ্যাঁ, এটা খুবই কম আর কি, এই স্টুডেন্ট মানে ভর্তি করাই অসুবিধা আর কি। হুম, ঠিক আছে। ওকে, সো ডু
স্যার
ইউ নো?
স্যার আমি শিওর নই, কিন্তু
আচ্ছা,
ট্রাই করতে পারি।
ইয়েস,
স্যার ম্যাঙ্গানিজ অক্সাইড।
just see manganese, it has many oxides like MnO2, Mn2O3, MnO, Mn2O7.
স্যার
So
Mn2O7।
Mn2O7, this oxide is only acidic oxide. Okay, thank you. So here you see that some of the oxides of
স্যার
huh,
স্যার বলছিলাম ক্রোমিয়াম ট্রাইঅক্সাইড কি
chromium trioxide also is acidic
স্যার
oxide.
ভ্যানেডিয়াম পেন্টঅক্সাইড হতে পারে।
Vanadium pentoxide, it has some amphoteric character, you can consider as, but vanadium pentoxide is not a good example for acidic oxide. uh, Chromium and manganese are a good example. Chromium, manganese, chromium trioxide and Mn2O7 both are acidic in nature. So here you see that sulfur trioxide is also non-metallic oxide, and it is acidic. When dissolved in water, it produces sulfuric acid. Now move on to next method for the preparation of sulfuric acid. That is the hydrolysis or the reaction with water of sulfuryl chloride. This is sulfuryl chloride. This is not sulfonyl chloride. Now another similar compound is there, sulfonyl chloride. Okay. Now this is not sulfonyl chloride. Sulfonyl chloride is SOCl2. Don't confuse with sulfonyl chloride and sulfuryl chloride. This is totally different compound. Sulfonyl chloride is SOCl2, that is that do not produce sulfuric acid on reaction with water, but you have to know this is sulfuryl chloride, SO2Cl2, that is sulfuryl chloride. When reacts with water, produces sulfuric acid and hydrochloric acid. This is again the two important acid produced in the same reaction. Now, what is actually sulfuryl chloride? Now, sulfuryl chloride, it is an addition compound. Now, sulfur dioxide is a compound, Cl2 is a compound. Now, when they in dry condition they react with each other, they produces SO2Cl2. SO2Cl2. This is addition compound. This type of compound is known as addition compound. But SOCl2 is not like that. SOCl2 is not an addition compound. Here you see that sulfur dioxide is a gas, chlorine is also gas. They react with each other with the formation of SO2Cl2. This is a new compound. So two different gases, they combined with each other with the formation of a new compound. This is also gas, vapor condition, it maintains its vapor condition. So this is the method. So here we discuss some important methods for the preparation of sulfuric acid. Though those methods are not applied in industry, but these are the laboratory method. In the laboratory you can use these methods for the preparation of sulfuric acid. There are four methods. One is starting from sulfur with nitric acid, another one is chlorine and sulfur dioxide in aqueous solution, another one is sulfur trioxide with water. Now this particular step is used in the industry but in different way. And the fourth one, that is the sulfuryl chloride, that reacts with water with the formation of sulfuric acid and hydrochloric acid. So these are the four different methods. But most important part of this chapter, I should say that most important part, that is the industrial method for the preparation of sulfuric acid. Now we should discuss the different aspects of this particular method. Now the contact process for the manufacture of sulfuric acid, this is the industrial method. Now previously there are two different methods for the preparation of sulfuric acid, and both are industrial method. One is the contact process and another one is the chamber process. But with the advancements of science, this chamber process is obsolete due to different limitations of this particular method. Now the only method in the industry that is used for the preparation of sulfuric acid, that is the contact process. Now in detail we should discuss the different steps of contact process. Now this is the one important flowchart diagram. Here you see that sulfuric acid manufacturing contains three steps. Sulfuric acid manufacturing in industry contains three steps. The first step of the production of sulfur dioxide, in the second step production of sulfur trioxide, and the third step production of sulfuric acid. Now each and every step is important, not due to the fact that different types of chemicals are used in those particular steps, but the steps are important only because of the fact that each single step that contains the several number of steps to execute exactly the purified product that is the form in the chemical reaction. So I should say that sulfur dioxide preparation in the laboratory is most important only because of the fact that sulfuric acid is so important chemical that that is used to prepare the other different types of salts. So any type of sulfate salt or any type of the acid that should be prepared by the use of sulfuric acid. So sulfuric acid, initially I have mentioned that sulfuric acid is known as the king of chemicals. This is only because of the fact that the sulfuric acid is termed as king of chemical only because of the fact that sulfuric acid is so important chemical that it can be used to prepare different types of inorganic compounds, inorganic acids, etc. The very important salts. So the sulfuric acid is so useful. That's why sulfuric acid is termed as the king of chemicals. So that sulfuric acid is produced by the three different steps in the industrial method. So each and every step we should analyze. Now the first step, the production of sulfur dioxide from sulfur. Now already we have mentioned that sulfur, not only sulfur but also some iron pyrides that reacts with oxygen with the formation of sulfur dioxide. So the first step, you can prepare sulfur dioxide starting from sulfur or starting from iron pyrides. In the second step, this sulfur dioxide that is produced, that should be purified. So several steps are there to remove dust particles, to remove oxides of iron or arsenic, etc. How to remove, we should discuss. Now the another part, the catalytic oxidation of sulfur dioxide to sulfur trioxide. Sulfur dioxide is converted into sulfur trioxide by the use of vanadium pentoxide as catalyst. Temperature, pressure, etc. also important. And conversion of sulfur trioxide into oleum. Now sulfur trioxide, it attached to it, dissolved in sulfuric acid with the formation of H2S2O7. And the last step, that is the dilution of oleum to sulfuric acid, when oleum is dissolved in water with the formation of sulfuric acid. So here you see that 1, 2, 3, 4, 5. Now 5 different steps are involved in this process, starting from sulfur or iron pyrites and ended with the concentrated sulfuric acid or even sulfuric acid, as you like, as your requirement. The concentration should be um, should be you can arrange that type of concentration by mixing different amount of water. If you add greater amount of water into oleum, then you should get dilute sulfuric acid, or you should get concentrated sulfuric acid when very less amount of water is added into oleum. Now the technical importance of each and every step, that is most important part of this manufacturing process. Now starting from the first important thing, that is the raw materials. Now each and every industrial process, you see that there is requirement of some raw materials. Here you can use the raw material, that is the sulfur, raw sulfur, that is the brimstone or sulfur ore, where from you get the sulfur, or you can directly use sulfur dioxide. This is very much less used industry. Most of the cases sulfur is directly used, or pyrite. Pyrite means the iron pyrite, having formula Fe(S)2, and also the air, source of oxygen, water are used. So sulfur, iron, pyrite, air for oxygen, and water, these are the raw materials that is used in contact process for the preparation of sulfuric acid. Now the next one, that is the different parts and their functions. Here you see a pictorial flowchart diagram of the preparation of sulfuric acid. Now starting from very left, what are the different parts and the different function of those parts? Initially you see that first part, that is the A. This one is the first important part. What is A? This part A, mentioned as A, is blower. A is blower. What is the function of blower? This blower used for the passage of purified air or oxygen. Now air is purified, and through this blower, air is blown into this container that is mentioned as B. Now what is B? B is a container which contains sulfur or pyrite. So B is known as sulfur or pyrite burner. So here start from A. A is a pump or blower that blows pure air or oxygen into B. B is known as sulfur or pyrite burner for the production of sulfur dioxide by burning sulfur or iron pyrites. What is the function of B? What happens in B? B is a container that produces sulfur dioxide by the reaction between sulfur and oxygen, or you can say iron pyrites and oxygen to produce sulfur dioxide. So here from air is blown by using blower A, and that air passed into B, which contains sulfur or iron pyrites, and that reacts with the formation of sulfur dioxide by burning sulfur or iron pyrites. Now after B, move on to C. Move on to C. This is C. Now what is the function of C? What happened in C? C is actually known as dusting tower. Dusting tower. Now what is the function of dusting tower? Dusting tower means the mixture of sulfur dioxide that is produced in B and the air obtained contains various impurities. Though it is mentioned that the air, purified air, is used in this method, but because of the fact that air contains various number of impurities, that impurity is contaminated with sulfur dioxide, which must be removed in C, only because of the fact that after that we use catalyst for the conversion of sulfur dioxide to sulfur trioxide. Now see, this is very important. Sulfur dioxide should be converted into sulfur trioxide in the next step. First step, sulfur is converted into sulfur dioxide. But this sulfur dioxide is contaminated with air and also with other type of impurities. Now, if this sulfur dioxide is used for the conversion of sulfur trioxide, then in this step, vanadium pentoxide catalyst is used. Catalyst is most of the cases, catalyst loses its efficiency in presence of dust particles or the pyrite dust or the arsenous oxide. These impurities are mainly, there are dust particles, pyrite dust, uh, iron, when you use iron pyrites, then pyrite dust is contaminated with sulfur trioxide, and also the arsenous oxide. These are the important impurities that is contaminated with the sulfur dioxide. Now this mixture is passed through a purifier or the dusting tower. This is dusting tower. This is called purifier, in which electric charges attract the solid particles which are removed. Here some electrical plate arranged, and the electrical plate, they attract the dust particles to remove from the sulfur dioxide. And dusting tower, it is very useful, not only because of the fact that it can remove the dust. Unless and otherwise you remove the dust particles, then those dust particles, they act as catalyst poison. They can contaminated with the catalyst, and catalyst in presence of dust particles loses its activity, loses its efficiency, and the most important step, that is the sulfur dioxide to sulfur trioxide, would be very much difficult if the efficiency of the catalyst is very less. So dusting tower is one of the important steps. So what we get knowledge from this dusting tower, that dusting tower is used to remove most of the cases the dust particles those are present in the air that is contaminated with sulfur dioxide, along with some pyrite dust or arsenous oxide. But those pyrite dust or pyrite dust, in some cases, this is also dust and they can be removed in this particular step, but arsenous oxide is not removed in this step. So dusting tower mainly removes the dust particles and also the pyrite dust, most of the solid particles. Now come to the next part, that is the cooling pipe. One of the important part here you see written over here, this is the cooling pipe and also the step, also the container, that is a D. Now first it is the cooling pipe. Now what is the function of cooling pipe? Now here you see that when the sulfur reacts with sulfur or iron pyrites reacts with air, the gas is formed at an elevated temperature. Gas is having quite high temperature, like 200 to 300 degrees Celsius temperature. Now this gas should be passed through cooling pipe for the cooling of the gas, at a normal temperature, because the further reaction should be done in cold stage, that is the tower D. The tower D is known as scrubbing tower. What is the function of scrubbing tower? Scrubbing tower, where the gas is laid into a water scrubber where it is completely freed from dust particles by the downward spray of water. Now here you see that sulfur dioxide along with some dust or arsenous oxide, that is after cooling come to this particular container, and where from downward spray of water from above, that confirms the, if at all there is some sort of dust particles present, then those dust particles should be removed by this step. The step C, or this particular step can be used to remove the dust particles, but the 100% removal of dust particles is not so easy. So after C, the step D is also used to remove the dust particles, only because of previously we have mentioned that only because of the fact that if any dust particles present in the gaseous mixture, then that dust particles contaminated with vanadium pentoxide, and the rate of reaction or efficiency of the catalyst should be decreases, and that's why it is quite important to remove the impurities. So there are so many steps used for the removal of those impurities. So scrubbing tower is one of the important part. Dusting tower can be used to remove the dust particles, and also the scrubbing tower, they do the same thing, same function, but in a different way. Scrubbing tower, water is sprayed downward to remove the dust particles. Now after the step D, then come to E. Here, step E. Step E is actually known as drying tower. Now drying tower actually it dries the wet gases that is actually formed during the passing of gas through D tower, because in D tower the downward spray of water, and this downward spray of water is mixed with some moisture, is mixed with the gases. So in step E, or the container E, here the drying of the moist gases done by the downward spray of concentrated sulfuric acid. Here the downward spray of concentrated sulfuric acid. Now this concentrated sulfuric acid actually concentrated sulfuric acid is a good water absorbing agent. So concentrated sulfuric acid absorbs any moisture present in the gases. Gas means sulfur dioxide. So concentrated sulfuric acid readily removes those moisture from the gas, and now this sulfur dioxide gas come to next step, that is the F. Now previously we have already mentioned that the sulfur dioxide, it contains some dust particles or the pyrite dust, and also the arsenous oxide, etc., arsenous impurities. Now dust particles are completely removed, pyrite dust is also removed, but the arsenous oxide or arsenous salt, they are not removed till now. So this F step is important for the removal of this impurity. So come to F. This is known as arsenic purifier. This is known as arsenic purifier, and this arsenic purifier, from the name you can guess that arsenic purifier is used to remove the any arsenous salt is present with the gases, that is sulfur dioxide. So the gas mixture is passed over ferric oxide or the ferric hydroxide. Maybe anyone can be used, ferric oxide or the ferric hydroxide. So this is known as arsenic purifier, and arsenic purifier can be used to remove the any arsenic impurities that is present in the gaseous mixture. After arsenic purifier, the gas mixture is go through testing box, where in a dark background it is confirmed for testing the purity of the gases by passage of light through a dark box. Now if any dust particles are present in the gaseous mixture, then that can be identified in this particular step. But in this step we remove nothing, but we only confirm that there is no impurity present before we let into the gaseous mixture into the catalyst. We confirm that there is no dust particles present in the gaseous mixture. So that's why this is the function of testing box. Testing box means this type of box where a strong beam of light in the black dark background, strong beam of light is passed, and in the dark background, when you see the gaseous mixture in a strong beam of light, you get the idea about the presence of any dust particles present in the gaseous mixture. So this is another important method. Here is the testing box. And after it is confirmed, after it is confirmed that testing box, from the testing box, that there is no dust particles, present, then there is no dust particles present, then that gaseous mixture is laid into G step. This is the G step. Now what is G? Now this particular step is the most important step in this method. What happened to G? Now here the pure, first thing you can say that sulfur dioxide is pure. It is devoid of any sort of impurities and also dried. So here you see that clean, dried gaseous mixture of sulfur dioxide and air is passed through a tower loosely packed with vanadium pentoxide or platinum. Any catalyst you can use, but vanadium pentoxide is cheaper. That's why vanadium pentoxide is favored in the industry. Here, preheated mixture of sulfur dioxide and oxygen forms sulfur trioxide. This is the most important step in this process. This step is known as contact tower or oxidation chamber. In this tower, sulfur dioxide reacts with air or the oxygen with the formation of sulfur trioxide. In presence of vanadium pentoxide catalyst, temperature around 450 degrees Celsius and pressure around 1 to 2 atmosphere. So in this step, sulfur dioxide reacts with oxygen with the formation of sulfur trioxide. This reaction is exothermic, very much exothermic, having 45,000 calorie energy is liberated by this method. So this reaction, this is most important reaction that is occur in contact process, and this reaction is reversible. Actually, sulfur dioxide reacts with oxygen with the formation of sulfur trioxide, and at the same time sulfur trioxide even converted back to sulfur dioxide and oxygen. This is exothermic reaction, and also the volume decreases by this method. Here you see that 2 volume of sulfur dioxide and 1 volume of oxygen, total 3 volume, but here you see that 2 volume of sulfur trioxide is formed. So volume is decreased by this method, in this method, and the reaction is quite exothermic in nature. This reaction is performed around 450 to 500 degrees Celsius at a pressure of 1 to 2 atmospheric pressure. Now, one important thing I want to mention here, that is if the reaction is exothermic. Now note it down. If the reaction is exothermic, then low temperature favors the forward reaction. If the reaction is exothermic, like this is exothermic reaction, the low temperature favors the forward reaction. So this reaction, this sulfur dioxide plus oxygen equals to sulfur trioxide, this reaction actually going to happen at a low temperature. But here we use that 450 to 500 degrees Celsius temperature, which is quite a high temperature. Now, why we should use some higher temperature? Why we should use some higher temperature in this case? Though this principle is known as Le Chatelier principle. Le Chatelier principle. In this principle, it is stated that if the reaction is exothermic, then low temperature favors the forward reaction. Now, if the low temperature favors the forward reaction, that is the formation of sulfur trioxide, then why we should use such a high temperature, that is the 450 to 500 degrees centigrade? Can we perform this reaction around 50 degrees Celsius or 100 degrees Celsius or less than that? Because already last year it is mentioned that if the reaction is exothermic, this is reaction is highly exothermic, that is 45,000 calorie energy liberated. So if the reaction is exothermic, then low temperature favors the forward reaction. But after that, why we should use the temperature like 450 to 500 degrees Celsius? Only because of the fact that if the temperature is very low, then rate of the reaction will be slow, because in lower temperature, the forward reaction only will happen according to last clear. But the problem is that rate of the reaction will be slow. That's why some optimum temperature means not too high, not too low, that type of temperature is used in this method. So 450 to 500 degrees Celsius is the optimum temperature. That is the terminology you should remember, optimum temperature. Now, why we should use optimum temperature? Only because the fact that if you want to execute this reaction, the low temperature favors. But if you use very low temperature, then the rate of the reaction will be slow and the production of sulfur trioxide will be very, very slow. In order to overcome this problem, the temperature around 450 to 500 degrees Celsius used, only because of the fact that at this temperature the reaction is moderate, and also the rate of the reaction will be such that we can afford in industrial process. So the G step is over and sulfur is converted into sulfur trioxide after this process. Now, after the formation of sulfur trioxide, this is absorption tower H. This is absorption tower H. Now, in the absorption tower, sulfur trioxide absorbed in sulfuric acid. Absorption of sulfur trioxide takes place. Sulfur trioxide is not dissolved. Here you see, this is important. Sulfur trioxide is not dissolved directly into water. Now, previously we give the reaction like sulfur trioxide plus water sulfuric acid. Then why we should dissolve sulfur trioxide into sulfuric acid to form oleum H2SO7? Only because of the fact that when sulfur trioxide dissolves into water, it gives out a lot of heat, and that heat causes the formation of fumes. Formation of lots of sulfur trioxide is removed at the atmosphere, and that's why sulfur dioxide not directly dissolved into water. Sulfur dioxide cooled in a heat exchanger, and it is then absorbed in sulfuric acid. When sulfur trioxide absorbed in sulfuric acid, then that particular step can be executed easily. But if the sulfur trioxide is dissolved in water, then those sulfuric acid form, but the reaction is highly exothermic and water is boiled, and most of the sulfur trioxide gas removed at the atmosphere, That's why sulfur trioxide is not directly mixed with water. It is mixed with sulfuric acid, the formation of oleum in this particular step. Now, after the formation of oleum, then come to last step, that is the dilution tank. Here you see that this is the dilution tank. Now in the dilution tank, sulfuric acid is soluble in all proportion, and dilution of oleum. Now the oleum H2S2O7, that oleum is dissolved in water with the formation of sulfuric acid. So the sulfuric acid having desired concentration is obtained by this process. So there are so many steps: A, B, C, D, E, F, testing box, G, H, and the dilution tank, GH, you can write as I. So there are so many steps. Each and every step I discuss. Now just remember what we have mentioned. That is, first, A, blower; B, sulfur or pyrite burner, where sulfur or pyrite burns to form sulfur dioxide; C, dusting tower, where the dust particles and the pyrite dust are removed by the downward spray of downward spray, by the use of electrical charges. After that, cooling pipe, through it the gas is cooled, and after that, scrubbing tower means it also removes the dust particles by the downward spray of water. And after that, E, that is the drying tower, where the gases should be dried by the use of concentrated sulfuric acid. And after that, arsenic purifier, that is purified, removing arsenous oxide by passage over ferric oxide or ferric hydroxide. And after that, testing box, which can test is there any dust particles present in the gaseous mixture, and if it is confirmed that there is no dust particles, then that gaseous mixture is next step. Sulfur dioxide cooling contact tower, where the oxidation of sulfur dioxide in sulfur trioxide by the use of vanadium pentoxide, temperature around 250 degrees Celsius, 450 to 500 degrees Celsius, and after, where the sulfur dioxide is converted into sulfur trioxide. After the formation of sulfur trioxide, that sulfur trioxide is not directly dissolved into water, that is dissolved with sulfuric acid with the formation of oleum. And after the formation of oleum, it is diluted in a dilution tank with the formation of sulfuric acid in a desired concentration. Is it clear to all of you? Just the process we have discussed. বলো সবাই বুঝেছো কি না? উর্বি, প্রত্যেকটা স্টেপ বোঝা গেছে?
হ্যাঁ স্যার।
Okay. Nirav, is it clear to you, all the steps?
Yes, sir.
You have to know the function of each and every step. One important fact is that you have to know what is the function of each and every step. What is the function of dilution tank? What is the function of scrubbing tower? What is the function of dusting tower? And which chemicals or which the process is employed in that particular step. So we just discuss the different parts and their functions. Next class, we should complete this particular chapter by some reactions. Already we have mentioned the different reactions in this particular method, and after that we should discuss the physical and the chemical properties of the sulfuric acid. And next class we take a subjective test on periodic classification, not the test we have already taken, that is the short answer type, not the short answer type test. Some questions like explanatory question or the reasoning based question, this type of questions we should on the basis of this type of question we take an exam on next day, and after that we complete the sulfuric acid chapter. Okay, thank you. After sulfuric acid chapter, can you start with chemical bond chapter or anything else? আমরা কি সালফিউরিক অ্যাসিডের পরে কেমিক্যাল বন্ড চ্যাপ্টারটা শুরু করতে পারি নাকি অন্য কিছু?
The acid basis salt.
হ্যাঁ,
হ্যাঁ স্যার,
Acid
অ্যাসিড
basis
বেস
salt.
সল্টস।
অ্যাসিড বেস সল্ট। ওকে,
হ্যাঁ
অ্যাসিড বেস সল্ট আরেকটা ব্যাচে পড়া হচ্ছে, ঠিক আছে। ওকে, নো প্রবলেম এট অল। We should after completing this particular chapter, then we should start with acid base salt. Okay, so good night সবাইকে, bye.
গুড নাইট স্যার, থ্যাংক
Nice.
ইউ, বাই স্যার।